Hello students, how are you all? I hope that you all are good. And my name is Rakesh Kanaganti. Welcome to our beautiful physics channel, Rakesh Sir Physics. In this session, I am going to discuss about basic mathematics used in physics, class number 1. So in this session, I am going to discuss about completely trigonometric functions. The first topic is trigonometric ratios and standard values of trigonometric functions and 4 quadrants and ASC rule, and the last topic is trigonometric formulae and a small angle approximation. So all these concepts are going to teach in this session. Okay, let's start the session. Basic mathematics used in physics, and this is a class number 1, right? So the first topic is trigonometric ratios. Trigonometric ratios. So before going to discuss about trigonometric ratios, we know about a right angle triangle. So all we know already about a right angle triangle. So one of the angle is a 90 degrees, right angle 90 degrees, that is 90 degrees, and it is called a right angle. So let us say this is an angle theta. The side which is opposite to an angle theta is called what? Opposite side. And the side which is towards the angle theta is called the adjacent side, and the side which is opposite to 90 degrees is called the hypotenuse. So this is about a right angle triangle. So from this right angle triangle, I am going to write the first function of trigonometrics, that is a sine theta. What is sine theta? Sine theta is nothing but opposite side by hypotenuse. Opposite side by hypotenuse. Sine theta is equals to opposite side by hypotenuse. And the second one is cos theta is equals to adjacent side by hypotenuse. Cos theta is equals to adjacent side by hypotenuse. And the third formula, tan theta is equals to, tan theta can be also known as the ratio of sine theta by cos theta, or the ratio of sine theta and cos theta is called tan theta. So what is sine theta? Opposite side by hypotenuse divided by what is cos theta? Adjacent side by hypotenuse. So hypotenuse get cancelled out, and we get a opposite side by adjacent side. So the formula for tan theta is what? Opposite side by adjacent side, and the tan theta can also known as the ratio of sine theta and cos theta. Fourth one, cot theta. So cot theta is nothing but the ratio of cos theta to sine theta. The ratio of cos theta to sine theta. What is cos theta? Adjacent side by hypotenuse divided by what is sine theta? Opposite side by hypotenuse. So hypotenuse get cancelled out, and we got a cot theta is equals to adjacent side by opposite side. Adjacent side by opposite side. If you observe carefully, tan theta is nothing but opposite side by adjacent side, and cot theta is nothing but adjacent side by opposite side. That means we can write cot theta is equals to 1 by tan theta. The reciprocal of tan theta is nothing but cot theta. Are you getting? See, cot theta is equals to adjacent side by opposite side. Tan theta is equals to opposite side by adjacent side. That means if we make the reciprocal of tan theta, we get cot theta. Right? Next formula. Fifth one, sec theta. What is sec theta? The reciprocal of cos theta is called a sec theta. The reciprocal of cos theta is called a sec theta. So sec theta is equals to, what is the cos theta ma? Cos theta is nothing but adjacent side by hypotenuse. and this hypotenuse comes to numerator and it becomes hypotenuse by adjacent side. So sec theta is equals to what? Hypotenuse by adjacent side. What is cos theta? Adjacent side by hypotenuse. Just to make the reciprocal of cos theta to get sec theta. See, adjacent side by hypotenuse. Hypotenuse by adjacent side. Opposite. That means reciprocal of cos theta will give sec theta. Sixth one, cosec theta. So cosec theta is nothing but the reciprocal of sin theta. The reciprocal of sin theta is called a cosec theta. So 1 by, what is sin theta? Opposite side by hypotenuse. So now this hypotenuse comes to numerator and it becomes hypotenuse divided by opposite side. So what is this? Cosec theta. So cosec theta is what? The reciprocal of sin theta is called a cosec theta. What is sec theta? The reciprocal of cos theta is called a sec theta. What is cot theta? The reciprocal of tan theta is called a cot theta, or the ratio of cos theta and sin theta is also called as cot theta. Tan theta. What is tan theta? The ratio of sin theta to cos theta. The ratio of sin theta to cos theta is called what? Tan theta. Sin theta is equals to opposite side by hypotenuse and the cos theta is equals to adjacent side by hypotenuse. Okay, so these are called trigonometric ratios. Okay, pause the video and write the notes or take the screenshot. Are you clear? Okay. Right. Now I'm going to discuss one example problem. Okay. So the example problem is, if sin theta is equals to 3 by 5, sin theta is equals to 3 by 5, then find the values of remaining trigonometric ratios. T means trigonometric. Okay, T stands for trigonometry. So what he is given? He is given solution. Sin theta is equals to how much? 3 by 5. What is the trigonometric ratio of sin theta? From right angle triangle, we can write opposite side by hypotenuse. Okay, that means the value of opposite side is 3 and the value of hypotenuse is 5. So just substitute these values in right angle triangle. Hypotenuse is equals to how much mark? 5. What is opposite side? 3. And we don't know the value of adjacent side. But from Pythagoras theorem, if we know the values of any two sides in right angle triangle, we can find the value of the third side by using Pythagoras theorem. So what is Pythagoras theorem? Hypotenuse square is equals to side 1 square plus side 2 square of right angle triangle. So hypotenuse is how much? 5 square, which is equals to side 1 is nothing but what? 3 square plus side 2 is nothing but what? We don't know, we have to find. Okay, so 5 square is nothing but 25, which is equals to 3 square is equals to 9 plus s2 square. So if we bring this 9 to this side, it becomes negative 25 minus 9 is equals to s2 square. 25 minus 9 is nothing but 16, which is equals to s2 square. If square come to this side, it becomes root. Therefore, s2 is equals to root over 16. What is the value of root 16? Root 16 is nothing but 4 whole square under root. So 2 and root get cancelled out. So we get s2 is equals to how much? 4. So what is the value of adjacent side now? 4. Now we can easily find all the trigonometric ratios. So what is the first one? Cos theta. Cos theta is nothing but what? Adjacent side by hypotenuse. What is the value of adjacent side? 4 divided by hypotenuse. What is hypotenuse? 5. So the value of cos theta is equals to how much? 4 by 5. So second one, tan theta. What is tan theta? The ratio of sin theta to cos theta. What is the value of sin theta? The value of sin theta is 3 by 5. And what is the value of cos theta? 4 by 5. 5 get cancelled out. We get 3 by 4 for tan theta. Are you getting? Right. So third one, cot theta. What is cot theta? Either you can use the ratio of cos theta by sin theta or the reciprocal of tan theta, whatever it is. I'm using reciprocal of tan theta. Both gives same answer. So 1 by, what is tan theta? 3 by 4. And 4 comes to numerator and it becomes 4 by 3. So cot theta is equals to how much? 4 by 3. So next one, fourth one, sec theta. What is sec theta? The reciprocal of cos theta is called a sec theta. So what is the value of cos theta? 1 by, cos theta is nothing but 4 by 5. And 5 comes to numerator and it becomes 5 by 4. So the value of sec theta is equals to how much? 5 by 4. Is it clear? Shall I rub this? Okay. Next one. Fifth one, cosec theta. What is cosec theta? The reciprocal of sin theta. The reciprocal of sin theta is called a cosecant theta. So cosec theta is equals to 1 by, what is the value of sin theta given? 3 by 5. And 5 comes to numerator and cosec theta is equals to 5 by 3. So all these are the remaining trigonometric ratios. Is it clear? Any doubts? So take the screenshot and write the notes or pause the video and write. Right. So our next topic is 4 quadrant and ASTC rule. 4 quadrant, 4 quadrant and ASTC rule. What is ASTC? A stands for all, S stands for silver, T stands for tea, and C stands for cups. Have a look. 4 quadrants. Okay. Right. I'm taking this point as a 0 degrees. That means I'm taking this point is a starting point, and this angle is a 90 degrees because this side is perpendicular to this side. So that's why here 90 degrees. From starting point, this point is at a 180 degrees. See, semicircle. Okay. From starting point, this point is at a 270 degrees. Okay, and ending point, the point of one rotation close at a 360 degrees. Is it clear? So this is 0 degrees, our starting point, and this point is at a 90 degrees, and this point is at a 180 degrees, and this point is at a 270 degrees, and the final point is 360 degrees. So, and start the rotation. Let us consider, here I am taking a straight line. This is called the origin O. From the origin O, a line OX is starts rotating. Let us consider. Now this straight line rotating in a anti-clockwise direction. Then it starts from 0 degree, 1 degree, 2 degree up to 90 degrees. That means this quadrant lies at a 90 minus theta degrees. That means up to 89 degrees this straight line will be rotates in this quadrant. Is this clear? Let us consider this is a straight line. It starts rotating in anti-clockwise direction. So it starts from 1 degree, 2 degree, 3, 4, 5, 6 up to 89 and 90 degrees. So that means whatever the quadrant is in this plane is lies at a 90 minus theta degrees, because less than 90 up to 90, that means less than 90. So now this quadrant, let us call this is a first quadrant. Okay, this is what second quadrant, and this is what third quadrant, and this is fourth quadrant. Okay, so this quadrant lies at a 90 minus theta degrees, and this quadrant lies at a 90 plus theta, because again it starts from 91, 92, 93 up to 180. So 90 plus theta, if you want to get 92 degrees, you have to add for 92 degrees, 90 plus 2 degrees, 92 degrees, like that. So again we can write this quadrant is also lies 90 plus theta and 180 minus theta degrees. Okay, so now this quadrant is at a 180 plus theta, because this quadrant starts from 181, 182, 183 up to 270. That means this quadrant is greater than 180 plus theta degrees and less than 270 minus theta degrees. Is it clear? Right. Fourth quadrant. This fourth quadrant is greater than 1 because it starts from 270. That means 270 plus theta degrees, and it is less than 360 minus theta degrees. Now this line started rotating and completes one rotation. That means it covers 360 degrees for one rotation. Again it starts rotating. Now what is its angle? 361, 62 for second rotation. We consider as 361 degrees, 62 degrees, 63 degrees and so on. That means again for second rotation this first quadrant becomes 360 plus theta degrees. Is it clear? Okay, so 90 minus theta, 360 plus theta. So this is the first quadrant. The second quadrant has 90 plus theta and 180 minus theta. Third, 180 plus theta, 270 minus theta. And fourth one, 270 plus theta, 360 minus theta degrees. Okay, 1, 2, 3, 4. Let's see. In this quadrant, all trigonometric ratios are positive. Okay, ASCC rule. In ASCC rule, A stands for all, S stands for silver. Okay, so T stands for tea, and C stands for cups. All silver tea cups. That means in first quadrant all the trigonometric ratios are positives: sin theta, cos theta, tan theta, cot theta, sec theta, cosec theta. So all the trigonometric functions or ratios are what? Positive in first quadrant. So first quadrant lies at a 90 minus theta and a 360 plus theta degrees. Is it clear? Right. In a second quadrant, silver. S stands for silver. Only sin theta and cosec theta. Only these two are positive. Only sin theta and cosec theta are positive. And remaining functions, what are those? Cos theta, tan theta, cot theta, sec theta, cosec theta. All these values are negative. Okay, so second quadrant, 90 plus theta and 180 minus theta, only positives for sin theta and cosec theta. For all remaining trigonometric functions, second quadrant is negative. Are you getting? Right? So third quadrant, T for tan theta and cot theta. The third quadrant is occupied by tan theta and cot theta for positive values. Only these two are positive in third quadrant and remaining are negative. So what are the remaining functions? Sin theta, cos theta, sec theta and cosec theta. So all these functions are negative in third quadrant. Is it clear? Negative. Okay. Fourth quadrant. C stands for cups. C for cos theta and sec theta. Only these two trigonometric functions are positive in fourth quadrant. Remaining all the trigonometric functions. What are the remaining trigonometric functions? Sin theta, tan theta, cot theta, cosec theta. So all remaining trigonometric functions except cos and sec theta are negative. So except this, remaining all are negative. Is this clear? So at 90 minus theta and 360 plus theta degrees, all trigonometric ratios or functions are positive. In a second quadrant, at 90 plus theta and 180 minus theta, at these two angles, only sin theta and cosec theta are positive. So remaining trigonometric functions are negative. At third quadrant, in third quadrant only tan theta and cot theta are positive. At what angles? 180 plus theta, 270 minus theta degrees. So remaining all functions are negative. Okay, so next one, cos sec are positive in fourth quadrant at 270 plus theta and 360 minus theta degrees. So remaining functions are negative in fourth quadrant. Is this clear? Is it clear? Okay. Now I'm going to write a standard formulas of trigonometric functions in our note number 1. So how the signs of sine and cos tan theta will be changes at these degrees. Note number 1. At 90 degrees and 270 degrees. At 90 degrees and 270 degrees, sine theta can be converted as cos theta. At 90 degrees and 270 degrees. Okay, and cos theta can be converted as sin theta. Okay, next one, tan theta can be converted as cot theta and cot theta can be converted as tan theta. Okay, so at 90 degrees and 270 degrees, sin theta can be converted as cos theta and cos theta can be converted as sin theta. Okay, and tan theta can be converted as cot theta and cot theta can be converted as tan theta. At what angles? 270 degrees and 90 degrees angles. So one thing is most important, that is must check their sign. Must check their sign. Okay, we have to check what? Their sign. Okay, if sin theta, cos theta and so on, all the trigonometric functions up to cosec theta, if they lies in their own quadrant, then they are positive. Sin theta, cos theta up to sec theta, all the trigonometric functions, if they are lies in their own quadrant, then they are positive. I will tell you how they are lying or not lying, like I will explain. Otherwise they are negative. Okay, if sin theta, cos theta, tan theta are lies in their own quadrant, then they are positive, otherwise they are becomes negative. Okay, so at 90 degrees and 270 degrees, sin theta can be converted as cos theta and cos theta can be converted as sin theta. Tan theta can be converted as cot theta and cot theta can be converted as sin theta, and we have to must and should we have to check their sign whether it is positive or not. When they are get positive, if sin theta, cos theta, sin tan, cot, sec, cosec up to cosec theta, if they are lies in their own quadrant means for second quadrant is one for sin and cosec. Third quadrant is one for only tan and cot because they are positive. Fourth quadrant is one for cos and sec because they are positive. Right. First one, sin 90 minus theta is equals to. Second one, sin 90 plus theta. Third one, sin 270 plus theta. Fourth one, sin of 270 minus theta. So from note 1, one thing is clear that at 90 degrees and 270 degrees, sin can be converted as cos and cos can be converted as sin, and tan can be converted as cot can be converted as sin. That is clear. So now we are writing at a 90 and a 270 degrees. So sin can be converted as cos theta cos theta, cos theta, cos theta. But the thing is, we have to check their sign, whether the functions are lying in their own quadrant or not at given angles. So what is the given angle here? Sine of 90 minus theta. Where is 90 minus theta? In a first quadrant. So 90 minus theta. In 90 minus theta, sine is what? Positive. Sine is what? Positive. Then the resultant becomes positive cos theta. So this is of checking the sign of given functions. Sine 90 plus theta. Where is 90 plus theta? Second quadrant. In second quadrant, sine is positive. Second quadrant, sine is positive. Then the result is positive cos theta. Third one, sine of 270 plus theta. Where is sine of 270 plus theta? Here, fourth quadrant. In fourth quadrant, only cos and sec are positive. Remaining all are negative. Sine is negative. So the resultant becomes negative. Are you getting? Are you clear? Right. Sine of 270 minus theta. 270 minus theta is in third quadrant. In third quadrant, sine is negative. Sine is what? Negative. So the resultant becomes negative. Is it clear? Any doubts? Right. Next one. For cos theta. Cos 90 minus theta. Cos 90 plus theta. Cos 270 minus theta. Cos of 270 plus theta. Right? Can you try once? Pause the video and try it. 1, 2, 3. Right, I'm explaining. At 90 and 270 degrees, cos can be converted as sin theta, sin theta, sin theta, sin theta. Now we have to check this angle belongs to its own quadrant or not. 90 minus theta is its own quadrant or not, we have to check. Cos 90 minus theta. 90 minus theta is in first quadrant. In first quadrant, cos is positive. So the resultant becomes positive. Okay. Cos 90 plus theta. 90 plus theta is in second quadrant. In second quadrant, cos is negative. Cos is negative. So the resultant is negative. Cos of 270 minus theta. Third quadrant. Cos is negative. So the resultant becomes negative. Cos 270 plus theta, fourth quadrant. Fourth quadrant 270 plus theta. And cos is positive in fourth quadrant. Then it becomes positive. Is it clear? Any doubts? Can we write for tan theta? Good. Tan theta. Right. Tan of 90 minus theta. 90 minus theta lies in first quadrant. In first quadrant, tan is positive. Okay. So tan is positive. So at 90 and 270 degrees, tan can be converted as cot theta, cot theta, cot theta, cot theta. And 270 tan 90 minus theta is first quadrant. In first quadrant, tan is positive. Tan 90 plus theta, second quadrant, tan is negative, and the resultant becomes negative. Okay. Third one, tan 270 plus theta. 270 plus theta is in fourth quadrant. In fourth quadrant, tan is minus. Then the resultant one becomes minus. Tan of 270 minus theta, third quadrant. Tan and cot are positive. Then the resultant becomes positive. That's it. That's it, guys. Any doubts? So take the screenshot and the write notes, or pause the video and write the notes. Your wish. Are you getting? Any difficulties there? Shall I rub this? Right. Okay. So the note number 2 is at 180 degrees and 360 degrees. All functions remains same but important thing is what? Check their sign. We have to check their sign, whether they are positive or not, whether in a given angle they are lying in their own quadrant or not. We have to check. Is it clear? Any doubts? Shall we write the formulas? Okay. First one, sine of 180 minus theta. Second one, sine of 180 plus theta. Third one, sine of 360 plus theta. And fourth one, sine of 360 minus theta. How we will check? At 180 and 360, sine remains sine. All functions remain same. That means here you will get sine theta, sine theta, sine theta, sine theta. But the thing is, we have to check the sign. Sine of 180 minus theta, where it is? Second quadrant. In second quadrant, sine is positive. So the answer is plus sine theta. Is it clear? Next one, sine of 180 plus theta, third quadrant. In third quadrant, sine theta is negative. So the resultant one is negative sine theta. Sine 360 plus theta, first quadrant. In a first quadrant, sine is positive. So plus sine theta. Sine 360 minus theta, fourth quadrant. Sine is negative. Minus sine theta. Any doubt? Any problem? Concept is clear? Right. Shall I rub this? Okay, good. Cos of 180 minus theta, cos of 180 plus theta, cos of 360 minus theta, cos of 360 plus theta. So how can we write 180, 360? Cos remains cos theta, cos theta, cos theta, cos theta. Cos remains cos. But the thing is, we have to check the sign. Cos 180 minus theta, second quadrant. In second quadrant, cos is minus. So the result is minus cos theta. Cos 180 plus theta, third quadrant. In third quadrant, cos is minus. So the result is minus cos theta. Cos of 360 minus theta. Where is cos of 360 minus theta? Fourth quadrant. In fourth quadrant, cos is positive. Then the resultant is positive. Cos of 360 plus theta, first quadrant. Cos is positive. That's it. Any doubt? Shall we write for tan theta? Okay. Tan of 180 minus theta, tan of 180 plus theta, tan of 360 minus theta, tan of 360 plus theta. So at 180 and 360 degrees, tan remains tan theta, tan theta, tan theta, and tan theta. But the thing is, we have to check the sign. 180 minus theta, second quadrant, tan is negative. That's it. 180 plus theta, third quadrant, tan is plus. 360 minus theta, fourth quadrant, tan is negative. 360 plus theta, first quadrant, tan is positive. That's it. Is it clear? Any doubts? Easy? Right. Now you can try to write a 180, 270, 360 and 90 degrees for remaining trigonometric functions. We have tried 3. Next, quarter, sec, cosec. You will try for those 3 trigonometric functions. Okay? Right. Note number 3. So the note number 3 is for 2n pi plus theta angle, sine, cos, tan and so on are remains same and are positive. where n is equals to 0 comma 1 comma 2 comma 3 comma 4. This is called a even function. Okay, so this is called what? Even function. So what he was saying, sine of 2n pi plus theta is equals to sine theta. No changes. Sine theta remains sine theta at 2n pi plus theta, where n stands for 0 1 2 3 4 5 and so on. If you substitute at the place of n 0, if you substitute 0 at the place of n, you will get a 2 into 0 into pi, 0 into something 0, you will get sine theta. If you substitute 1 at the place of n, 2 into 1 2, 2 into pi 2 pi, sine of 2 pi plus theta, 2 pi is nothing but what? 360, sine of 360 plus theta. First quadrant sine is positive, then sine remains sine. So likewise, if you do for cos theta, cos 2n pi plus theta, you'll get cos theta, and tan of 2n pi plus theta, which is equals to tan theta. Okay, at 2n pi plus theta, sine remains sine, cos remains cos, and tan remains tan. So this is a third note. Okay, so substitute the values 0 1 2 3 at the place of n, you will get the same function whatever you are taking. Is it clear? Is it clear? Right. So pause the video and write the notes or take the screenshot, your wish. Is it clear? Okay. So from this 4 quadrant and ASTC rule, one thing is clear that, see, sine theta and cosec theta are lies in second quadrant, sine and cosec are lies in second quadrant, and we can write cosec theta is equals to note, cosec theta is equals to reciprocal of sine theta. In a first concept, trigonometric ratios, I said that cosec theta is equals to 1 by sine theta, right? And cot theta is equals to reciprocal of tan theta. We write like this, right? And sec theta is equals to, sec theta is equals to 1 by cos theta. We are write like this in a trigonometric ratios. Have a look. The reciprocal of sin theta is nothing but cosec theta, because they are lying in a same quadrant. Have a look, sin theta and cos theta. The reciprocal of sin theta the reciprocal of sin theta gives cosec theta, and the reciprocal of cosec theta gives sin theta. Is it clear? Right. If you come to here, the reciprocal of tan theta gives cos theta, and the reciprocal of cot theta gives tan theta, because they are lying in a same quadrant. Come to here, cos theta, the reciprocal of cos theta gives sec theta, and the reciprocal of sec theta gives cos theta. So this is a small concept. So what are the trigonometric functions are lies at a same quadrant? Their reciprocal gives another trigonometric function. Is it clear? Right? Are you getting? Okay, very good. Standard values of trigonometric functions. Functions or ratios, whatever it is. Okay, standard values of trigonometric ratios. So here I am taking sin theta, cos theta, tan theta. These three are enough. Give some space in between them. Cos theta and tan theta. So if we know these three, we can write all other trigonometric function values at 0 degrees, 30 degrees, and 45 degrees, 60 degrees, 90 degrees, 120 degrees, 135 degrees, 150 degrees, and 180 degrees. Okay, right. The value of sine 0 degrees is 0. The value of sine 30 degrees is 1 by 2. The value of sine 45 degrees is 1 by root 2. and the value of sine 60 degrees is root 3 by 2, and the value of sine 90 is 1. Okay, so next, the value of cos 0 degrees is 1. Just write these values in reverse order. So cos 30 root 3 by 2, reverse order, just write the sine values in reverse order. So 1 root 3 by 2, cos 45 1 by root 2, cos 60 1 by 2, cos 90 0. I'm just wrote in a reverse order. These are straight or cross. These are very cross. Root 3 by 2, 1 by root 2, 1 by 2, 0. Okay, next tan theta. So what is tan theta? The ratio of sin theta to cos theta is called tan theta. So 0 by 1, 0 by something, 0, 1 by 2 divided by root 3 by 2. So root 2, 2 get cancelled out and we will get 1 by root 3. Let's write like this, 1 by 2 divided by root 3 by 2. So 2 2 get cancelled out and we will get 1 by root 3 for tan 30 degrees. Next, tan 45. For tan 45, sin 45 is 1 by root 2 and cos 45 is also 1 by root 2. Root 2 get cancelled out. 1 by 1 is nothing but what? 1. So tan 45 value is 1. Next, tan 60. Tan 60 is nothing but what? Sin 60 divided by cos 60. Okay. 2 2 get cancelled out. Root 3 by 1 means root 3. Next, tan 90. Tan 90 is nothing but what? Sin 90 divided by cos 90. What is sin 90? Sin 90 1. Cos 90 0. Something by 0 is nothing but what? Infinite. Something by 0 is nothing but what? Infinite. Is this clear? Is it clear? Any doubts? Okay. Let's be right for sin 120. So sin 120 can be written as, sin 120 degrees can be written as sine of 90 plus 30 degrees. Sine of 90 plus 30 degrees. Sine of 90 plus theta. Sine of 90 plus theta. At 90 degrees, sine can be converted as cos theta, where theta is 30 degrees. And we have to check the sine. Sine 90 plus theta. 90 plus theta is in second quadrant. In second quadrant, sine is positive. Then the answer is positive. What is the value of cos 30? Cos 30 is equals to root 3 by 2. Are you getting? So this is what? Root 3 by 2. Then second one, sin 135. So sin 135 can be written as sine of 90 plus 45. At 90 degrees, sine can be converted as cos 45, cos theta. Okay. Sine of 90 plus theta, second quadrant. In second quadrant, sine is positive. So plus cos 45. So cos 45 degrees is equals to how much? 1 by root 2. So here we get 1 by root 2. Similarly, sin 150. Sin 150 is nothing but sine of 90 plus 60. At 90 degrees, sine can be converted as cos 60. 90 plus theta is in second quadrant. In second quadrant, sine is positive. So what is the value of cos 60? Cos 60 is equals to 1 by 2. So here we get 1 by 2. Okay. Sin 180. Sin 180 degrees. So it can be written as sine of 90 plus 90. At 90 degrees, sine can be converted as cos theta, cos 90. So sine 90 plus theta is lies in second quadrant. In second quadrant, sine is positive. So the answer is positive cos 90 degrees. Cos 90. What is the value of cos 90? 0. Here we will get 0. Is it clear? Any doubts? I hope that. Okay, right. Very good. Good table. Okay. So cos 120. Cos 120 can be written as cos of 90 plus 30. Cos 90 plus theta, second quadrant. In second quadrant, cos is negative. At 90 degrees, cos can be converted as, sir, write on the board, sir. Don't tell all these things like that. Okay, let's see. Right. Cos of 120 degrees, it can be written as cos of 90 plus 30 degrees. At 90 degrees, cos can be converted as sin theta, that is sin 30 degrees. Cos 90 plus theta, second quadrant. In second quadrant, cos is negative. Sin 30. What is sin 30? 1 by 2. So minus 1 by 2. So here we get minus 1 by 2. Next one. Cos of 135. Cos 135 can be written as cos of 90 plus 45. So at 90 degrees, cos can be turned as sin theta. Cos 90 plus theta, second quadrant. In second quadrant, cos is negative. Sin 45 minus 1 by root 2. And here we will get minus 1 by root 2. Next, cos 150. Cos 150 can be written as cos of 90 plus 60. At 90 degrees, cos can be turned as sin 60. Cos 90 plus 6 theta, second quadrant. Second quadrant cos is minus sin 60 minus root 3 by 2. Minus root 3 by 2. Cos 180. Cos of 180 can be written as cos of 90 plus 90. At 90 degrees, cos can be turned as sin 90. Cos 90 plus theta, second quadrant. In second quadrant, cos is minus. Then answer is negative. Sin 90 minus 1. Sin 90 value is how much? Minus 1. Is it clear? Next. Tan. Tan is nothing but what? Sin theta by cos theta. So sin theta is root 3 by 2 minus 1 by 2. 2 to get cancelled out. Here we will get minus root 3. Here 1 by root 2 minus 1 by root 2. Get cancelled out. We will get minus 1. Are you getting? Here 1 by 2 minus root 3 by 2. So 2 to get cancelled out. Minus 1 by root 3 we will get. Minus 1 by root 3. Okay. Next one. 0 by something. 0. So these are the fixed values of sin theta, cos theta, tan theta from 0 degrees to 180 degrees. I hope how can we write the values. I hope you learned that how to write the trigonometric values at a given angle. Is it clear? Any doubts? Okay, one. If you want to write the cos values, just make in reverse order. Just write the value of sin theta in reverse order. See, 1 root 3 by 2, 1 by 2, sorry, 1 by root 2, 1 by 2, 0. In reverse order, see. So if you learn this, you can easily write cos theta values. If you learn sin theta values, then you can write cos theta values easily. How? Just write from cos 90 to cos 0 in reverse order. Okay. So for tan, just sin theta by cos theta, you will get tan theta values. Okay. So if you wanted to write a 120, 135, 150 and 180 degrees, see 120 is equals to root 3 by 2. Where is root 3 by 2? Here, cos 60, sin 60, sorry. Sin 60 is root 3 by 2 and sin 120 is also root 3 by 2. Sin 45 is 1 by root 2. Sin 135 is also 1 by root 2. Again write in reverse order. Okay. So 1 by 2. 0. Come here. Just place a negative sign and write in reverse order. You must place negative sign. Is it clear? See, minus root 3, minus 1, minus 1 by root 3, 0. Is it clear? Any doubt? I hope that you are clear this concept. Okay. So take the screenshot or pause the video and write the notes. Your wish. Right. So the next concept is standard formulas of trigonometric functions. So trigonometric formulas. So the first formula is sin square theta plus cos square theta is equals to 1. Sin square theta plus cos square theta is equals to 1. So from this formula we can write second one, sin square theta is equals to 1 minus cos square theta. Can we write like this? Sin square theta is equals to, if plus cos square theta comes to this side, it becomes negative minus cos square theta. So third formula, from the same formula we can write cos square theta is equals to 1 minus sin square theta. So place the cos square theta is here only and bring this plus sin square theta to this side, it becomes minus sin square theta. Is it clear? Right. Fourth one, sec square theta minus tan square theta is equals to 1. Secant square theta minus tan square theta is equals to 1. Fourth one, sorry, fifth one, 1 plus cot square theta is equals to cosecant square theta. 1 plus cot square theta is equals to what? Cosecant square theta. Sixth one, sin 2 theta. Sin 2 theta. We can write 2 sin theta cos theta. Sin 2 theta is equals to 2 sin theta to cos theta. Next, seventh one, cos 2 theta. So the formula for cos 2 theta is cos square theta minus sin square theta. Cos 2 theta is equals to what? Cos square theta minus sin square theta. And this formula is also can be written as cos square theta. This is also one formula minus what is sin square theta? Sin square theta is nothing but 1 minus cos square theta. This equals to cos square theta minus into plus minus 1 minus into minus plus cos square theta. Cos square theta plus cos square theta 2 cos square theta minus 1. So this is one formula and this is another formula. Okay, so we can write seventh formula, again continuing the seventh formula. Again cos 2 theta is equals to, what is cos 2 theta? Cos square theta minus sin square theta. So we are substituted sin square theta is equals to 1 minus cos square theta since second formula. From second formula we are substituted sin square theta is equals to 1 minus cos square theta. From third formula, since from third formula we can substitute cos square theta is equals to 1 minus sin square theta. So 1 minus sin square theta minus sin square theta. Are you getting? Cos square theta is nothing but 1 minus sin square theta minus sin square theta. Minus sin square theta minus sin square theta. What we will get? 1 minus 2 sin square theta. So this is also one of the formula for cos 2 theta. Is it clear? Next one. Eighth one. 1 plus cos theta is equals to 2 cos square theta by 2. 1 plus cos theta is equals to 2 cos square theta by 2. And ninth one, 1 minus cos theta is equals to 2 sin square theta by 2. 1 minus cos theta is equals to 2 sin square theta by 2. Is it clear? Right. These are the standard trigonometric formulas. Next we can write the formulas for sin A, sin of A plus B, cos of A plus B, and so on. Is it clear? Any doubts? So here we have some space. Let's we discuss some small note, important one. Okay, if any angle is negative in a sin theta, in sin function is like this: sin of minus theta, you will get minus sin theta. Sin of minus theta is equals to minus theta. I will give you one example. If the angle is like this, sin of minus 30 degrees. You will get minus sine 30 degrees. What is the value of minus sine 30? Minus 1 by 2. Are you getting? So let us say this is first one. The second one is, cos of minus theta, which is equals to cos theta. Are you getting? Example, cos of minus 45. Cos of minus 45. Is there any minus? No. If any angle is negative in a cos function, it becomes positive. Then you will get cos 45 degrees, which is equals to 1 by root 2. Similarly, third one, tan of minus theta. Tan of minus theta, which is equals to minus tan theta. Tan of minus theta is equals to minus tan theta. Any angle is negative in tan function, you will get minus tan of that angle, that value. So example, tan of minus 45 degrees. So minus tan 45 degrees, which is equals to minus 1. Tan 45 value is how much? Minus 1. Is it clear? Any doubt? So pause the video and write the notes or take the screenshot, your wish. Okay? Right. Right. Expansion formulas, trigonometric expansion formulas. The first one is sine of a plus b. Sine of a plus b, which is equals to sine a cos b plus cos a sine b. Okay, sine of a plus b is equals to sine a cos b plus cos a sine b. Second formula, sine of a minus b. Just put minus here, you will get sine of a minus b formula. So what is that? Sine a cos b minus cos a sine b. Is it clear? Third one, cos of a plus b. Cos of a plus b. So cos a cos b, here plus is there, just we have to write minus here. Cos a cos b minus sin a sin b. Is it clear? Fourth one, cos of a minus b, opposite to this, just place plus in middle of cos a cos b plus sin a sin b. Is it clear? Fifth one, tan of a plus b. Tan of a plus b, which is equals to tan a plus tan b divided by 1 minus tan a tan b. So tan of a plus b is equals to tan a plus tan b by 1 minus tan a tan b. So sixth one, tan of a minus b, just write opposite to this. So here plus is there, then we have to write minus here. Here minus is there, just we have to write plus tan a tan b. Okay, next formula, the last formula, seventh one, tan 2a. Tan 2a. So the formula of tan 2a is 2 tan a divided by 1 minus tan square a. Tan 2a is equals to 2 tan a by 1 minus tan square a. Is it clear? Okay, write the formulas, take the screenshot. Today's our last concept is what? Small angle approximation. Okay, so small angle approximation means if theta is, okay, if theta is less than 5 degrees, if theta is less than 5 degrees, then sin theta becomes theta. First one, if theta is less than 5 degrees, then sin theta becomes theta. Okay, don't write this. Second one, cos of theta. Cos of theta. Theta is very small. Here theta is what? Very small. Here also theta is very small. Then cos theta becomes 1. If theta is very small, then cos theta becomes 1. Third one, tan theta. If theta is very small, then tan theta becomes theta. Theta is very small. Very small means less than 5 degrees. Is it clear? Okay. So write the notes or take the screenshot, pause the video, write the notes or take the screenshot, your wish. Okay, right. So I discussed what? Trigonometric formulas, 4 quadrants and ASTC rule, trigonometric formulas and standard values of trigonometric functions, and small angle approximation. All these things are we are discussed in this session. I hope you are enjoyed this lecture, and we will meet in a next lecture. Stay tuned. This is Rakesh Kanganti. Jai Hind.